Hello, and welcome to this ANSYS Space Claim tutorial on smoothing, reducing, and regularizing a mesh STL. If you haven't already, go to File, Open, browse to the directory where you downloaded the file, and open up Space Claim STL Smooth, Reduce, Regularize.scdoc. You'll notice in the structure tree there's a number of different components, each with multiple meshes within them. I've put in duplicates here just so we can compare the before and after when we use the tools to smooth, reduce, and regularize. If you just open Space Claim, you'll probably be in the Design tab, so we want to go over to the Facets tab, where we're going to look at the three tools in the Adjust group: Smooth, Reduce, and Regularize. Remember, the Facets tab is an additional add-on. Now you may notice here in the tree under one scan that there's 4 different parts, but you only see 3 here. There's actually 2 in the middle. The first one in the tree is in the middle, and the third one in the tree is also in the middle. And I put those there so we can, again, compare the before and after. Now what we're going to do to start off is check out the Smooth tool and see how that works and what we can do with it. Now I want to smooth out this entire piece on the left, and if I do a box select around it, by default, it's not going to select all of the facets. Now I'm going to hit H to go back to a home view just so we're looking at it in the same way. And we have a couple different options. We could use the selection filter in the bottom left and change it to through, and that way it'll select even the facets that we can't see. Now to start off, it has 3,000 facets. And if we use the Smooth tool with the default settings and we click the check mark, I'm going to click in white space to deselect, and we can see that it visibly looks smoother. Remember here, it's a bunch of larger triangles with some fairly sharp points. And if we look at the same area on the one we just smoothed out, there are more triangles, and we don't see any of those sharp points anymore. It's a lot smoother. And if I box select this one that we just smoothed out, notice that there is just over 12,000 facets. So if we look at the smooth options on the left, there's an angle threshold and a smooth type. Now, if I hover over the Smooth tool and press F1 for more help like it says, it'll explain what those different settings mean. Now, smooth type, we have approximate and local. And the difference is that approximate will add triangles. It quadruples the number of triangles every time you use it. Local will not, and I'll show you when and why you might not want to do that. Now, the other option is the angle threshold with a default angle of 60. What this means is if it finds an angle above 60, it will not try to smooth it out. So if I zoom in here on this block right here, which was done using the default settings using approximate and 60, notice that these angles here, this is a 45-degree angle here and a 45-degree angle there, but these edges are 90 degrees. And notice in this one, it smoothed out what was less than 60, these 45s, but it did not smooth out this 90-degree angle that was greater than 60. So the threshold means anything above it, it will keep as a sharp edge instead of smoothing it, and anything under this value, it'll go ahead and smooth it out. But remember that the approximate will add additional triangles, quadrupling it each time in order to provide a smoother result. And if we do this one more time on this model, we'll see that it now has 48,000, and it is quite a bit smoother with even more smaller triangles. So the approximate option is good to use on an entire model. The local option does not add triangles, it just moves the existing triangles around. And to do this, I'm just going to hide a couple things in the tree. I'm going to hide the one that we just smoothed out, and I'm going to hide one of the 2 that are right here. Doesn't matter which one. I'm going to, as I hover over in the tree, it gets highlighted in the design window, and I'll just uncheck it to hide it, and now there's one right here. If I select the whole thing, it's the 3,000 facets that we started with, and I'm going to zoom in here, and I'm going to click this a number of times, maybe 5 or 6. 1, 2, 3, 4, 5, 6, maybe even more, 7, 8. It's hard to tell, but it's actually getting smaller. I'm going to escape out of the Smooth tool, and as I hover over this one in the tree, you can see that it's bigger than the one I just smoothed out. And that's what the local option does. It tries to smooth out the model simply by moving the existing points. Now, if we look at the difference between these, this does look a little smoother using the same amount of triangles, but the decrease in volume, that overall shrinking of the model, is usually not acceptable. So we typically don't see people using the local option on an entire model. What we see them doing rather is using it on a local section. And to demonstrate this, I'm going to hide the one I just made smaller, and I'm going to show the one that we didn't modify yet. So what it's really designed for is knocking down bumps. So here we have a bump on the model here, and I'm just going to select a bunch of the facets around it. Now it's selected some on either side because of that through option. Well, what I could do is if I hold down the control key and do another left to right box select around that extra area, it'll deselect them. And so I'm going to get into a good view so we can see the bump here. And I'm going to click the check mark a bunch of times. And you'll notice that every time I click it, those get smoothed out and flattened a little more. So that is the intent of the local option, not to be used on an entire model, but on a local region when you don't want to add additional facets, but you want to smooth out the facets that you already have. And so if I bring back the other ones, again, we can see the difference. Here we have the original model with a number of large facets. Here we have one that we did an approximate smoothing twice to add more facets and smooth out the model. And on this one, on one of them, we smoothed out the entire thing, making it quite a bit smaller. But the intended use of the local option is to simply knock down some bumps in a local region. Now I'm going to hit H for home just to go back to this original ISO view. And I'm going to hide the first one scan, and I'm going to show the next one, 2-part. And you'll see that there's 2 different parts here. Again, they're exactly the same, and we're going to modify one and leave the other just as a comparison. And for this one, I want to show that you can use the smooth option with approximate on a local region. So we may have this part that we want to print out, and if we zoom in, it's not extremely faceted, but it's not extremely smooth. We could see here the hole definitely does not look circular. But some of these other regions with the rounds, they look good enough. And maybe for the purpose of 3D printing, we don't actually need to smooth these out. However, we may be 3D printing this to do a fit check or a functionality check. And maybe there's a pin that goes through this hole. Now that pin is not going to go through this hole very smoothly with these faceted faces. So what I'm going to do is I'm going to try a few things out. First, I'm going to double click on one of these. And what's nice is it selects this entire loop. And I'm going to spin the model. So we're looking at from the top here. And with the approximate option on, I'm going to click the check mark a few times. 1, 2, we'll do 3 times. And if I zoom in here, we've added more triangles. If I look from the top, it does look like it's kind of been made into a circle, but really only through the middle. It's circular in the middle, but it's tapering back to this faceted set of edges at the top. So I'm actually going to undo 3 times. You can either use Control Z or there is an undo button at the top. And what I actually also want to do is I want to smooth out the faces on the top here. So I'm going to hold Control and double click there and hold Control and double click on the bottom. Now, again, I'm just going to rotate to the top so you can clearly see what's going on. And I'm going to click the check mark 3 times again. Once, twice, 3 times. And here it looks much closer to a circle, and you could always click it again if you need it even more curved. And you can see that both on the top, middle, and bottom of this hole, it's nice and smooth. And if it happens to be the wrong size, you could always use the pull tool in the design tab, double click here, and you are now able to pull this hole in and out in order to change the size. There are tutorials on using the pull tool in order to edit an STL found in the same section as this tutorial. But here I just wanted to show the ability to locally smooth out using the approximate option in order to add facets selectively on a part instead of on an entire part. Next, let's go ahead and hide 2-part and show 3 assembly. Now here we have an assembly, but whenever you bring in an STL assembly or a mesh assembly, the whole thing is always defined as one mesh body. Now, if I try to do a smooth operation on one of these here, and again, I just want to make sure it selects all the facets on either side, and I hit the check mark, it says failed to smooth mesh. And if I look in the tree, I can see this little yellow tag on here that usually means there's something wrong. So the first thing that we might do is do an auto fix on this guy right here, and I just click it, and now it looks okay in the tree. And now if I go back to smooth, box select this whole thing, and hit the check mark a few times, I'll do 3 times. It looks like it did a pretty nice job smoothing it out. We have the rounds on the edges here being a lot smoother. Same thing over here. But if I zoom in on where this pin is, you can notice a pretty bad problem here. In addition to making some faces have inverted normals, it smoothed it out on the top here, but not on the bottom. And that's because when an assembly is looked at as a single mesh body, it keeps the connections between each of the parts. So one thing that we usually need to do on an assembly before we smooth it out is separate them. So I'm going to turn on my separate tool, and on this one I'm going to click here, and that will separate this one from here, and I'll click that one. I'm going to click in the middle there, click on this part going down and this part going up. And now I'm going to go back to the smooth tool, select this whole thing, and click the check mark 3 times. Now I'm going to escape out of the smooth tool, hit escape twice, and zoom on in here. And we can see that we have the correct smoothing, the desired smoothing. We have a nice, clean cylindrical hole and a cylindrical pin, as opposed to over here when those actually remained attached. And as similar to the last part, we could always take the pull tool, grab some facets. We can double click in a couple different areas to grab the whole thing. And you can see that I can drag this bigger and smaller with the pull tool in order to get it to fit correctly. So sometimes the original part does not have the correct resolution, and smoothing it out on an assembly requires separating, and then other edits can be made to get the desired sizes. Now I'm going to go back to a home view with the H key, or there's a home view button up here, and we're going to hide 3 assembly, and we're going to go ahead and show 4 reduce. So I'm going to zoom in on here, and we can see from afar that there's some dense colored regions here. And if I go ahead and zoom in on some of them, you'll see that there are a lot of facets, probably way more facets than are needed. These facets are rather small. If in my measure tab, I use my measure tool, and I select, say, this point here, hold control and select this point here, we're getting a distance of 0.0043 millimeters. If we change that to inches, you could see that it's 2/10,000ths of an inch. Most printers don't have this resolution, and this resolution isn't really needed in order to get smooth prototype parts. So these here have too many facets. I'm going to escape out of the measure tool and box select one of these. And we'll see that we have 1.2 million facets. And 1.2 million facets may be way too many for this size and for the printer. So we want to take a look at the facets tool reduce in order to reduce that facet count. So again, I'm going to box select one of these. It doesn't matter which one. To get a nice box select, I might click on the Z axis down here in the bottom left. That just makes it easier to do a box select around this. We do want to make sure that all those facets are selected. And in the facets tab, there's this reduce tool. And I'm going to go ahead and just to show you how much it can reduce, I'm going to turn this up a little bit. The default value is a 20% triangle reduction, but I'm going to turn this up to, let's say 75%. So removing 3/4 of these, and I'll just hit the enter key to lock in that percentage. And now we'll go ahead and click the check mark. Now this operation does take some time. It is basically rewriting all the triangles to get a reduction of 75%. So I'm going to go ahead and pause the video and come back when this is completed in a minute or two. So now that that's completed, let's escape out of the reduce tool. So just as a point of reference, This one is 1.2 million facets. Here we did a 75% reduction. So reducing that by 3/4, we get 300,000 facets. So here we could see that we haven't lost really any detail on it. Here we could see some much darker regions, and that's because of the density of the facets. Here it's a little bit lighter here, and if we go ahead and zoom in, we can see larger facets. I can actually see the size of all the triangles from here. If we go ahead and look at the same corner on the other one, it's very dense, and I actually have to zoom in very far just to see the actual shape and size of those. So we can definitely see that here the reduce tool will lower the number of facets that we have, but not necessarily reduce the smoothness or the quality. And this is just so the printer can process the model a little quicker. Last but not least is the 5 regularized, and we're going to go ahead and show that. And I'm just going to hit H for home just to get back to our ISO view. And the question is, what is regularize? Smoothing, it tries to smooth out the model either by adding facets or not. Reduce simply reduces the facet count, but what exactly is regularize? So let's go ahead and hit F1 for more help. We'll make the help menu a little bigger here, and I'm just going to scroll down to regularize. So here, what the tool tries to improve the quality of the selected facets by making their aspect ratios more consistent. There's an angle threshold in terms of limiting when to regularize facets or not. But basically, in layman's terms, what it's trying to do is when you have triangles that are of varying shapes and sizes, it tries to make them more constant. So if we take a look at the two bodies that we have here, this is a scan. We could see that there are some small triangles, some large ones, some skinny ones, ones that are pretty equal in different sizes, ones that are a little more longer and irregular. And so we might want to regularize them. Now, you might be wondering, when and why do I want to use this tool? Well, you don't necessarily need to use this tool if you're 3D printing it. The main areas that we see needing this is if you're setting up a CMM machine, because a CMM machine looks at each point of the facets. So if you have long, skinny facets, you may not have as evenly distributed data. The second application is similar, and it's within space claim. It's if you have a scan of something and you want to reverse engineer it and you want to run a deviation analysis between the scan and the solid. What the deviation tool does is it compares the points on the scan to the actual solid geometry that you would model up, and it finds the minimum and maximum deviation and where the model is inside or outside of the scan. Now, if the points are not distributed very evenly, if there's a lot of long, skinny triangles, you may not get a good deviation. So we're going to take a look at how regularize can help with that. And to do that, I'm going to go ahead and click on the Z-axis here, just to make it easy to do a box select of one of these two. And again, we want to confirm that it grabs all of the facets. And I'm going to go ahead and turn on the regularize tool, and I'm going to go ahead and click the check mark. You could hit it a couple times, but it really does the bulk of the changes in the first iteration. Not much is done there afterwards. In fact, clicking it a few more times, you might notice some bad data here. So I'm actually going to undo the last two, and we can see that it doesn't quite make that as bad. But if we go ahead and look at these two different ones, here we could see some longer triangles, some smaller triangles, and here it's gone ahead and it's really distributed them a lot more evenly. Here we can see a couple long triangles followed, surrounded by some small ones. Here you could see that these triangles are much closer in size. Now, it's not going to try to edit the model too substantially. If all the triangles were the same size, you'd lose some of the definition. You'll notice over here, not much has changed. A lot of these already have a pretty constant aspect ratio. And so in some areas, you might not see a lot of change. Some areas you might. Just remember, you don't need to regularize every part. This is one of those tools that you might try running if something else doesn't work. The reduce tool as well. Some models won't shell or thicken. Sometimes reducing the count even by 5 or 10%, which really won't change the model substantially, will allow you to do other things that don't work. And we're noticing the same thing in regularize. Sometimes if you're not able to perform a more complex operation, doing a quick regularize to correct the aspect ratio on the triangles can help a lot. So just to cover everything we've done in this whole section, starting at the beginning, we took a look at a scan and the smooth tool, the differences between approximate and local, and doing it on an entire part and then an individual piece. In the second part, we reconfirmed that we can do it on just a individual area. We don't have to do it on an entire model, even when using the approximate option. In the assembly section, we took a look at some of the issues of not separating an assembly into individual parts, and then what it looks like if we actually do separate those out. We took a look at reducing triangles when there are just too many triangles in a design. Maybe someone saved it with a resolution much higher than the 3D printing machine. And then last, we took a look at regularizing triangles to correct their aspect ratio. So I hope this has all helped. Thanks for watching and have a great day.